Continue the topics, continue the problems of Euclid's division lemma. I will write the question on the board. Use Euclid's division lemma to show that cube of positive integers is of the form 9m or 9m plus 1 or 9m plus 8. Okay, using Euclid's division lemma to show that cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. This we have to prove. So what we have to prove about cube of the positive integers? First you have to know what are the cubes of the positive integers. So I will write here some examples. 1 cube means 1 into 1 into 1, 1 ones are 1, 1 ones are 1. Next is 2 cube, this is the cube. 2 into 2 into 2, 2 to the 4, 4 to the 8. 3 cube. So these are the cubes. 3 cube is 3 into 3, 9 to the 27. So this we can also write as 9 into 3. 3 cube means 3 into 3 into 3, 3 3 is a 9 and 9 3 is a 27. So this we can also write as 9 into 3. Here I am multiplying 9 with 3. This we are going to use because in the question you have to prove it is in the form of 9m plus 1 or 9m plus 8. Because of this 9, what we are doing, we are taking multiplying with the 3. Before we prove this cube of the positive integers, we are going to prove just the positive integers, about the positive integers. First, apply as per Euclid's division lemma. In this kind of problems, always you have to write this step. As per Euclid division's lemma, A and B are positive integers. There exist Q and R. Right, Q and R are also positive integers such that A is equals to BQ plus R. Same thing, this division, this equation we are going to apply in every problem. A is equal to BQ plus R, and what is the condition? 0 less than or equal to R less than B. Always we have to use this whenever the question comes like this. You have to prove the division problems based on the Euclid division's lemma. We are going to apply this. The next thing is, now to prove this, what we are doing? First, instead of taking B as a 9, what we are doing, we are taking it as 3. Because whenever 9 gets multiplied by 3, we will get the cubic number. We will get a cubic positive integer. That's why. Why only 9? Why only 3? We can also take this now. If the question comes like this, 4m, in this type of questions we can multiply with 2. Because the question is given 9m, we are multiplying 9 with 3 so that it is a perfect cube. Whenever you multiply 9 with 3, we are getting a perfect cube. So let A be some positive integer. Right, we are not proving cubic. First we are taking just a positive integer. Let A be a positive integer and B is equal to 3. In this case we are taking B is equals to 3. So same thing we will apply over here. Okay, right, this remainders. What about the remainders? 0 less than and equal to R and less than 3. The remainders will be 0, 1 and 2. Because remainder is less than 3, it is greater than and equal to 0. Equal to 0, so we are taking 0. Greater than 0 means 1. Less than 3 means 2. So these are the 3 remainders. Now we are having 3 cases to prove. Right. Now what are the cases? First one, take remainder 0, then remainder 1 and then remainder 2. These are the 3 problems you have to do. Now in this case we have A is equal to 3q plus remainder 0. So it is nothing but 3q. A is 3q. In the second case, A is equals to 3q plus 1 because remainder is 1. Right. Here A should come. And then here A is equal to 3q plus remainder 2. So these are the 3 positive integers. A is equal to 3q, a is equal to 3 cube plus 1 and a is equal to 3 cube plus 2. These are the three positive integers. Based on that, what we have to do in this question, we have to prove about the cube of positive integers. So now let's start finding the cubes. Because in the question it is given cube, we will do the first one, taking a is equal to 3 cube. What we are doing, because it's a cubic question, apply cube on both sides. Apply cube on both the sides. That means a cube is equal to 3 cube whole cube, right? So a cube means 3 cube into cube. This power 3 applied to both these terms, 3 cube into cube. The next is 3 cube means 3 into 3 cube. Now what about this 3 into 3? 9. 9 into this, we are not going to multiply, we are just taking it common here. So cube will come here. 9 3 cube. So this we can write as 9m. 3 cube we are writing as m. That means m is nothing but m is equal to 3 cube positive integer. It is a positive integer. So see what is the answer we are getting? Cube of the positive integer. A is a positive integer. Cube of the positive integer comes in the form of 9m. That only we have to prove. What are the three steps? What are the three terms? 9m, 9m plus 1 and 9m plus 8. These three answers we should get. So first answer we got based on the question, case 1, taking the remainder 0, applying cube on both the sides. This is the positive integer. Cube of the positive integer is nothing but we got 9m. So it is coming in the form of 9m. First one is finished. Now we will do for the second one, taking the remainder 1. Second case. Now we will continue the second case, that is taking remainder r equals to 1. Case 2. After taking remainder 1, we got a is equal to 3q plus 1. So what we can do over here? Since we have to use for the cube, we are applying cube on both sides again here. If the question is like that, square of any positive integer, we have to apply square. Since the question is about the cube, we are applying cube here also. A is a positive integer, applying cube on both sides. A cube is equal to 3 cube plus 1 whole cube. Right, a cube is there. What about this one? 3 cube plus 1 whole cube. It is an identity. It is of the form a plus b whole cube. You have to recognize the identity, that is a plus b whole cube is nothing but a cube plus b cube plus 3a square b plus 3a b square. This is an identity we have to use here. In the place of a, we have 3 into q. This is complete a plus b. In place of b, we have 1. So apply over here. Use the right side identity. So here, a cube means 3 cube. 3 cube whole cube we have to use. Right. The next is plus b is nothing but 1 whole cube plus 3 into a square. Again in the place of a we have 3 cube, 3 into, so you have to multiply 3 into 3 cube, 3 cube square is also there, square into b is nothing but 1 here, 1, okay, right, plus again we have fourth term 3 into a is 3 cube, 3 cube into b square is 1 square. Now again 3 cube, 3 into 3 cube. We are writing 3 as 3 into 3 into 3. This 3 is applied for both this 3 and q also. So for 3 we are applying cube, 3 into 3 into 3 into q. For q also we have to apply this cube plus 1 cube means 1 into 1 into 1. 1 1 1 1 plus 3, again square is there. 3 ones are, this is in multiplication. So 3 ones are 3, 3 square means 3 into 3 q square. I am splitting this 3 into 3 plus here 3 into 3, 3 3 is a 9 q. Okay, 1 square is 1 1 is 1, so 3 1 is 3, 3 3 is 9, 9 1 is 9 q. Now why I am writing this? Now from here we can take 3 3 is 9, here also we can take 3 3 is 9. 9 into 3q cube plus 1 plus again 3, 3 3 is 9q square plus 9q. We have to take 9q because in the question you have to prove 9m plus 1. Because of that we are taking 9 as common. So can you see here we are having 9 here, 9 here, 9 here. In these 3 terms we can take 9 common because this is complete one term, this is also one term, this is also complete one term. So from this term we can take 9 common. We are taking 9 common, make the bracket. So what is left out terms here? 3q cube plus we are taking out 9 common. So what is left here? 3q square. 3q square plus here also we are taking 9 common. So what is left? Q. Right. The left number is 1. We can't take 9 common here. So plus 1. So this is equals to 9. This complete term, this is now it is 1. It became one term. 9 into this is 3q cube plus 3q square plus q. So this one we are taking it as m. 3 into m plus 1. Okay, now as we are getting 9m plus 1. So cube, a cube. Can you see this? A is a positive integer. Cube of positive integer comes in the form of 9m plus 1. Second one. So second one is finished over here. What about m? Where m is equal to, you have to write this 3q cube plus 3q square plus q, some positive integer. So 9m and 9m plus 1 are finished. A cube, cube of the positive integer comes in the form of 9m and 9m plus 1. Okay, I hope you have understood. Now what about this? The last one we have to prove. How can we prove it? By taking what is left here, remainder r equals to 2 is left. For remainder 1 we have done, for remainder 0 we have done, for remainder 2 we have to do. So let's continue for third case. Remainder 2 means we are taking remainder 2. A is a positive integer, it is in the form a is equals to 3q plus 2. Then because we have to prove cubic, again same thing, we are applying cube on both sides. So here we will write a cube is equals to 3q plus 2 whole cube. We can write this identity again, a cube plus b cube plus 3a square b plus 3ab square. This is an identity we are using here. Now a cube is equal to 3q plus 2 whole cube. Now can we do this? In the place of a we have 3q. You have to apply this identity. This is the left hand side over here. We have to write in the right hand side form. Now this is a is nothing but here 3q whole cube plus in the place of b we have 2 here. So 2 whole cube plus 3 into a. In the place of a we have 3q square into b. In the place of b we have 2. Right, first term, second term, third term plus last term 3 into, in the place of a we have 3q into, in the place of b we have 2 square. Square is also there. While writing you should be very careful while writing the this terms. A cube is there, cube, square, square. So here cube is there, cube is there. This is completely one term, 3a square b. You should be very careful. 3 into 3q whole square into b, right, plus 3 into a. 3q into b is 2 square, right. Don't skip this. If you forgot to write this means the answer will be wrong. So be careful while writing this. Now this equals to, let us apply as we have done in the previous case. 3 cube is nothing but 3 into, okay, 3 into 3, right. 3 cube we are writing as 3 into 3 into 3. This cube is also applied for q, plus 2 cube means 2 into 2 into 2. 2 cube, this 2 cube we can write, I also wrote here, you can able to see. 2 cube is 2 into 2 into 2 plus 3 into 3 cube whole square. Square is there, that means square applied for both this 3 and q, that is 3 into 3 q square. I am writing 3 square as 3 into 3, q square as it is I am writing, into 2 is also there, okay, plus this I am writing here, okay, this is 3 into 3, 9, we write q into 2 square. 2 square means 2 into 2, 2 to the 4. Now here we can write 3 into 3 into 3. We want 9 as a common term. So we are multiplying it. 3 into 3, 9. 9 into 3q cube plus 2 to the 4, 4 to the 8 plus 3 into 3, 9. 3q square, okay. 3 to the 6 we have to write here. 3 3 is a 9, right. So here 2 is also there. 3 to the 6 q square plus 9 as it is we have to write. We can multiply with 4, but no need to multiply because we have to take out 9 common, so we are not multiplying. 9 into, always number should be first, you write number first, then q, variable term. Q is a variable term, we have to keep as it is, then it is left. Now can you see this, 9 is here, 9 is here and 9 is here. 8 is separately you have to write. In these 3 terms we can take 9 common. 3q cube plus 6q square plus 4q. These 3 terms over plus 8. Okay. Then 9 into this complete, this became one complete term. What we can do, this complete term we are writing just as m. So we will write it as m. 9 into m, okay, right, 9m plus 8. So can you see we got the third one, 9m plus 8. 9m plus 8, right. So the third one is also here. What is m? M is nothing but just it is an integer. So where m is equals to 3q cube plus 6q square plus 4q. M is equal to this, some integer, some positive or just some integer we can write. Some positive integer. So what we have to prove, the cube of, using the Euclid's division lemma. Euclid division lemma is nothing but division method, that is a is equal to bq plus r. That equation you should satisfy. Using that equation we have proved that 9m plus 1 and 9m plus 8, the cube of the positive integers comes in this form. 9m we got first, we have proved 9m plus 1 also we have proved, last one we got 9m plus 8 also. So cube of any positive integers comes in the form of 9m or 9m plus 1 or 9m plus 8. That also you can write over here. After this statement you have to write the statement. So as we got cube of positive integer in this form, so therefore cube of positive integers are in the form of uh, 9m or 9m plus 1 or 9m plus 8. So this is the answer. Hope you have understood.